Hello and welcome to this informational video brought to you by 323help.com. My name is Martin Johnstone and I'm going to be delivering this video to you today. And we are going to cover traditional systems with a single operating system versus the newer virtual systems technology or clustering technology of today. And the main software that we're going to focus on is called Proxmox. So currently, most businesses are still utilizing single operating system server technology, which means you have one server, and that one server has one operating system on it. This was largely due to the technology, the actual hardware that was on the server itself. Didn't necessarily have the capability to run multiple operating systems on it smoothly. Now, for some of you, this may be a very new concept in regards to being able to put more than one operating system on a computer, but this technology has actually been out for years. It's been used on what's been referred to as mainframe systems, where literally at times you can have hundreds of motherboards inside a given computer, oftentimes running multiple operating systems and distributing various processes across those processors. But in our case, in the typical business, people have been using such things as Windows Server, Windows NT, with all its different flavors, and just that one operating system on one computer servicing its entire network. And this has been a limiting factor. A lot of people don't know that, but it's been limiting just because the operating systems themselves have not been set up for scalability. Redundancy, meaning having multiple systems running the same processes or backing each other up, or there for failover. And but now with newer server technologies, including Proxmox, which gives you a very easy way of setting up multiple computers on a cluster setup, meaning you have multiple computers basically working together to deliver services to other computers on a network. So with virtual systems, you have, yes, one computer still, but with the correct hardware on that system, you can have a server which has a virtual system on it that can then have multiple operating systems on it. Now with Proxmox, as I mentioned earlier, that system in particular can run operating systems such as Windows, Linux, or actually almost anything you want on it. So that means, let's say for example, at home you want to use this as a solution for yourself. You can place the Mac operating system, the Windows operating system, Linux, and almost anything else you want on there. You can find it on the internet if you look up how-tos and tutorials on how to install all these various operating systems. It's totally possible, particularly now that since Mac has switched over to an Intel processor base. You can now use that on a virtual system. Okay. In my case, I use multiple servers, but I use nothing but Linux, so I just run different flavors of Linux on the same piece of hardware, and yeah, that's my operating system of choice is Linux, particularly Ubuntu. Okay, so how is it that a virtual system is built for scalability, expansion, handling overload? It's not set up for overload, but it's actually set up for handling overload and backup. Well, because one system has multiple operating systems, what's happening is that you have this overall operating system. Is actually when you install Proxmox itself is based on Debian, which is a type of Linux. It actually acts, as you could say, like a mother to the remaining operating systems that you install in the system. So that one overall operating system monitors and controls to some degree all the processes running on the individual operating systems installed inside of that. So back here, for example, when we first start out, actually what we have is you first have Proxmox here, which is a flavor of Debian, or you could say it is Debian but modified. And this system is the first thing that you install into the computer, usually installed by CD-ROM. Then once you have that in there, you would then bring in containers, which would be the various operating systems like Ubuntu, Slackware, and so forth. Those would then run inside of that. Once you install it, you can set up all the parameters, giving it, how much processor usage you want it to have, disk space, and so forth, which can actually be modified runtime. So let's say one of your servers here, one of your operating systems is running low on memory. You can simply go into the Proxmox web interface. If you do have memory left over, or even if you just have hard drive space, you can always increase the swap space, which is a type of memory, and your system can then continue to run that operating system without failure. So within Proxmox, it has the ability to basically cluster, which means that you set up one system as your master, and then the remainder as nodes or slaves. So essentially this one system then dictates to the others which processes to run, which things to help out with. And actually these would both be hardware nodes, because in the case that when you're going to be running a cluster setup with Proxmox, you would have one server set up initially with your containers installed. You would go through the process of installing the operating systems inside of it. It actually takes just 2 command line arguments to basically set up Proxmox on a server system. You run one on the server to basically tell it, yeah, you're the server, you're the master system, and you run a second command on a slave or a node, which tells it's the node and tells it to connect with the server. The systems then sync. The syncing process on current hardware, for example, a Core 2 Duo system, maybe 3 gigahertz, 4 gigs of RAM, a SATA hard drive will sync in approximately 3 to 5 minutes, even if you have 4 containers running on your master. So why is this important? It's important because in any business, even when you start off, let's say for example, with 3 to 5 employees, you may start off with 2 systems, and you may not even choose to do a cluster setup when you first start. You may have one just set up for redundancy, and